Hi guys, in today's video we are going to see the first 4 database normal forms. There are 6 in total, but the first 4 are the most important ones. Very briefly, we have to mention that database normalization is the process of structuring a relational database according to some rules in order to reduce data redundancy, or in other words, duplicates, and enhance data integrity. We have this dataset here with the customer, the items they bought, the shipping address, the newsletters they subscribe to, the supplier's number, and the prices for each item. So the first normal form says each cell has to be single valued. The second rule says entries in a column must be the same data type, and the last one says the records has to be uniquely identified. So we need to add an extra column with a surrogate key. Based on that, we can see that our data set complies with the second rule. All the records in the columns are of the same data type, so we comply with the second rule, but we do not comply with the first rule and the third one. So the first rule says each cell has to be single valued. But if you check in the highlighted columns, we have in the first record, Alan Smith purchased 3 items and has subscribed to 3 newsletters, and we have 3 different suppliers, 3 different suppliers numbers, and 3 different prices for each item, separated by commas, and this is not normalized properly. What we need to do is to split each value into a different record, and the result would be something like this. So after we would have 3 separate records for this Alan Smith. There are 2 Alan Smiths, by the way, but they live on different addresses. So if you check record number 2 and number 3 and number 4, this is the first Alan Smith we had in the before table, and we have split the values. So here we have 1 record for the PlayStation item that has 1 subscription to the PlayStation News, 1 supplier, Sony, and the supplier's number, and 1 price. Then he bought an Xbox and he subscribed to Xbox newsletter, and the supplier is Xbox, and the supplier's number is this one, and the price is a different one for Xbox, of course. And then for the last one is the PC. The newsletter is the Microsoft News, and the supplier is Microsoft, etc., etc. So we split 1 record into 3 records, and we also added a surrogate key for the customer, like for the customer ID. I will show you how you can do that right now. Before I start with the actual query, I want to show you how we can create hierarchies in Oracle SQL, because we are going to use the connect by clause here to create hierarchies, and the level keyword. So if I run select level from dual connect by level less than equals 4, we are going to create a sequence of numbers. But how does this work in the background? So how do we come up with 1, 2, 3, and 4? If we use the sys connect by path and level, we pass level as a parameter, from dual connect by level less than equal false, you will see here the whole path, because the child connects to the parent. So the first record would be 1, the second record would be 1, and then 2. So 2 connects with its parent, which is 1. The third record would have 1, then 2, then 3. So 3, the parent of 3 is 2, and the parent of 2 is 1. And the last one is 1, goes to 2, goes to 3, goes to 4, and we get the last value. So 1, 2, 3, 4. Okay, now that we explained that, let's move to the actual query. Our base table is the info table, so if we select from this table, you will see the results you saw on the PowerPoint, right? Now we need to split, as we said, the values into multiple records. We can do that by using this query here. Sorry about that. So this is the first query that we need to use. You see, we use the regex substring, so we get for each column, for let's say for the item column, we have to split the values as we said, and then we have to do the same for the newsletter column, the supplier column, the supplier's number column, and the prices. We use substring, and we separate the string into commas, and then we use this parameter here is the level that we use in the connect by clause. Now that we created a hierarchy of numbers, actually a sequence of numbers using the connect by level, let me show you how this expression actually works. So if we select the substring for the item column and we separate the string by commas and we use here level 1, you will notice that it returns 4 records. The first one is PC, PlayStation, Xbox, PlayStation, and these records are for each customer. But if we pass here level 2, this is what we actually do in the query, it will return the PlayStation, which is the second number for the first customer that we had. Remember, we had three items. The first customer purchased 3 items, right? So this is the second item for the first customer, and for the rest of the customers we don't have any values, right? So if we do, let's say level 3, level 3, it will give us the last value, the Xbox value, and for the rest of the customers this is null, of course. Let's go back to the query and run this again. Here we look at the length of the string of let's say we pick the item column, but you can pick the other columns as well, newsletter or supplier number or price, and then we look at the length of the string without the commas, and we can determine the number of commas we have in a string. And if we add +1, because we can surmise that we always have one more value than commas. And here, if we run this query, you will see 12 values. Now, why are we getting 12 values instead of 6? Because the connect by clause provides you all the combinations for each relation between child and parent, right? And that's why we need to use a distinct keyword, and that will return 6 values as expected, and this is the correct one. Now remember, we said we need a surrogate key for the customer, a customer ID. We can do that by using a dense rank. We don't need the distinct here anymore because we used it in the inner query, but we need to use dense rank, which is an analytical function, and we need to order by customer name and shipping address, and that would return a customer ID. So if we do that, you will see we get a customer ID for each unique customer. I remember we have 2 Alan Smiths, but they live on different addresses, so they are different people, but it happens they have to have the same customer name. Let's create a table. We can create a table which is called updated info and us, and we use the select. So it's a very easy way to create a table. It's already being used, so we have already created, but let's drop it first and then rerun the statement, create, and we created the updated info. So now if we select from the updated info, you will see the updated table with 6 records instead of 4. And we have normalized the table based on the first normal rule. This is our updated table now. We have the customer ID and we have 6 records. Now the second normal form says that all attributes non-key columns depend on the key. But as you can see here, the price is not related to the customer ID. It's completely irrelevant. And we cannot have that. So we need to split this table into two tables. One for the customer that will contain all the information for the customer, and for one table for the item which would contain all the information regarding the item. And at last we would need a transactions table that will contain all the transactions. Let's go back to the SQL and see how we can do that. We need to select the distinct values of customer ID, customer name, shipping address, newsletter from the updated table. If we run the select statement, it would give us 6 records with unique values and only information about the customer. Let's create the customer table, create table customer as, select distinct all these values from the updated table. Great. And conversely, we need to create the item table, and we need to create a item ID here using the dense rank function again, over order by item descending order, then select the item, the supplier number, and the price. So if we run this query, we will get information only about the item. I need to add the supplier ID using the dense rank function, but let's this is only for the third normal rule, but I have to add it from now. But let's ignore this supplier ID for now. Pretend it doesn't exist for the second normal form. And last but not least, we need to create the fact table with all the transactions. If we select the customer ID and the item ID from the updated table, let's do that. Oops, invalid identifier. Why is that? Column 42. Okay. Yeah, sorry about that. This item ID, this dense rank function should not be here. It should be in the updated table one step before. Sorry guys, I forgot about that. We need to add it here. I had it here, I commented out, but it has to be here. So if we recreate this table, the updated info table, it won't change anything, as you will see, and then create it, the updated table again, and we need to drop this item table and recreate it. And now let's recreate the item table. Okay, that's perfect. And let's drop the fact. We didn't create the fact table yet, so let's create that. Perfect. And that could give us all the transactions between, the customer ID and the item ID. This is how we connect those two tables. Okay, now that we have normalized the table based on the second normal form, we need to move on to the third normal form. Right now we have these tables here, but the third normal form says that all columns can be determined only by the key in the table and no other column. As you can see, the supplier here, each supplier has only his own supplier number. So this number belongs to Microsoft only and not Sony, and this number belongs only to Sony, and this number belongs only to Xbox. But what if we add more records in the item table? Let's say an item coming from Microsoft again. If we change the supplier's number, we have to change it in multiple places. So this is not normalized properly. We have to split the item table into two tables, one for the item and one for the supplier. The item table would contain the supplier ID, and we would connect the supplier as a foreign key, and we would connect the item table with the supplier table based on the foreign key, and the supplier ID would have only supplier information. That's why I created the supplier ID on the previous step, to have it as a foreign key on the next step and recreate the item updated table. So we need to select distinct, the item ID, item supplier ID, which is the foreign key now, and the price. Right? If we create this table, and then we need to create the suppliers table, that could contain the supplier ID as a primary key, the supplier, and the supplier number. Let's create this table as well and see what it gives back. And we have 3 unique records. Now that we have performed normalization based on the third form, we have to move on to the fourth normal form. Right now we have these tables: the customer table with all the customer information, the transactions table which connects the customer table with the item table, and the item table which contains the supplier ID as a foreign key and connects to the supplier table. So 4 tables here. But the fourth normal form says no multi-valued dependencies. That means here that Alan Smith, let's say Alan Smith has subscribed to 3 newsletters, right? What if he unsubscribes from one? What is going to happen to the shipping address? Is it going to be null? Or let's say he moves to another place and he has 2 shipping addresses. What are we going to put in the newsletter column? Null again. So we need again to split this table. And we need to create 2 tables, one with the customer ID, the customer name, and the shipping address, and one which would contain the customer ID and the newsletter. And it would have 6 records, because the new customer table would have only 4 records, 4 unique records for each customer. We have 4 customers, so we have 4 records. Each customer can subscribe to multiple newsletters. That's why we created this new table. Let's see the code for that. We need to create the new customer table that will contain only the customer ID, the customer name, and the shipping address, and we select the distinct values because we need one record for each customer. If we run this query, it will bring back 4 records, one for each customer as expected. Let's create the table. First, let me drop the table if it already exists, and let's recreate it. And then we have to create the newsletter table that will contain only the customer ID and the newsletter. Remember, it's one-to-many relation. So if we select here, we will get 6 records because one customer can subscribe to multiple newsletters. So customer 2 here has subscribed to Microsoft News, PlayStation News, and Xbox News. And let's create this table again. Yeah, great. We have reached the 4th normal form, and now we have the customer table which has only unique values. If we change the shipping address for one customer, we don't have to update it on multiple places, just one place. And if we add a new record, if let's say the customer subscribed to a new newsletter, we don't have to worry about the shipping address because those tables are independent now. Why star schemas are more popular than normalizing the tables? Because normalizing the tables based on those rules is better for fast writes. Instead, using star schemas is better for analytical queries and for fast reads. However, both are very important, and as a data engineer you will use both. This is the end of the video. If you like the video, please click the like button and subscribe to the channel for the next one.